All right, good evening, folks, or good afternoon, or good morning, based upon the time zone you're located in. Well, welcome. If it's your first time, then definitely welcome. If you are a regular attendee of this Compose Camp, then welcome back. A few of the familiar faces over here in person as well. Well, this is the third session. So let's take a quick look at today's agenda and then we're going to start learning. So, well, first things first. For those of you who don't know me, I'm Sagar. I'm a staff Android engineer working at Vivint Smart Home. I've been working in the Android domain for 9 years now, and I love front end and mobile operating systems in general. I'm also a Google Developer Group organizer. Our group is called Boston Android, and I live in Boston. So here's a group which I just talked about, Boston Android, and these are my amazing co-organizers, Beth and Jin. So you can join our group using the meetup link, which is displayed on the screen. We also have a Slack group. The URL for that is on the screen as well. So if you ever have like any question related to tech or you need some kind of advice in your career, you are just getting started in the industry, or you have been a veteran in the industry, you just want to brainstorm some ideas, then feel free to reach out to us. So we have got like different channels. Most communication happens in the general channel, so feel free to ask questions related to tech or Android or leadership in general. So we do our best to help you out. If you have any like passion projects or GitHub repos, so definitely feel free to share it over there. And for the purposes of Compose Camp, we also have created a dedicated channel called Compose underscore Camp underscore Summer, where you can share your learning progress as and when you are encountering new stuff related to Jetpack Compose or Android in general. So yeah, feel free to join that channel. And yep, a special shout out and thanks to Anton and Rafael from Accenture who have been kind enough to lend the space to conduct this event in person. Well, yep. And here's the agenda for today. So, in the last two sessions, we learned all about the basics. In the first session, we focused more about what composables are and how to create a composable and how do you preview a composable. In the second session, we had a guest speaker, Dan, who was from Peloton. There, we learned more about like a little bit of event and state management, a little bit of animations. So stuff like if you have a button and then you click on the button, how do you actually handle all of those on-click events and stuff like that? So today we're gonna take a look at the compose phases, meaning like what exactly happens behind the scenes, what are the exact steps involved from an operating system level to display your UI elements from the Kotlin code which you write to the format in which the user visualizes them in their device. And we're going to take a look at Compose lifecycle and how to handle side effects and at which place in the code. It's important to learn about Compose lifecycle because the traditional way of handling lifecycle events using classic toolkit of Android, that is using XML, has been different because uh, in the XML way of things, the lifecycle of an activity or a fragment has a lot of like different callbacks on create, on start, and all of those things, but none of those lifecycle methods are applicable for Compose. So let's say you are creating an app in 100% Compose. So you would definitely want to learn how to handle all of those lifecycle events and all of those things. And last but not the least, we will be taking a look at Compose navigation. So that would be like a code lab exercise. So we would be following along a bunch of steps and we'll be coding along and we'll see what kind of progress we make for the evening. All right, now let's start diving deep into the topics. So let's focus on the phases in Compose. Now, in the first session, I introduced the concept of declarative programming, and declarative programming is the modern way of programming where we actually tell the declarative framework in order to what needs to be done, and the framework takes care of achieving the desired operation. So, in other words, we can say the compose framework converts data into UI. You essentially tell the compose framework, like, here are a set of like maybe string values or image resources you provided to the framework, and then it gets rendered into UI. So under the hood, the compose framework renders the UI in three different stages. So the first one is called composition, the second one is called layout, and the third is called drawing. So let's take a look at what happens in all of those individual stages. Yeah, we can also say in the composition stage, the operating system or the compose framework decides what needs to be rendered. In the layout phase, it decides where it needs to be rendered. And in the drawing phase, how it needs to be rendered. So in the composition phase, so let's say you have a very basic composable with a bunch of columns and rows. For folks who missed the first and second session, a quick recap on column and rows. These are nothing but the modern way of writing down like a view group. In the classic XML way, we have a linear layout and relative layout, but the compose equivalent for it is like row and column and so on. And icon and title are nothing but individual composables, uh, the views, if you may, in the classic XML terminology. And so what happens in the composition phase is the compose frameworks renders a UI tree where each of these nodes which you see over here are also termed as like layout nodes, but each of these resemble or represent one of the composables which is written in your code. Now, for example, this can also be translated into like in somewhat like this. You have got a row, a row view group, and then underneath image column and all of those individual composables. Um, or did we lose connection to the display? Let's see.
Yeah, you disconnected
Yeah,
his video.
I think it should be back. Yeah, there we go. Okay, perfect. All right. Yeah, sorry for the interruption. There was like a technical problem over here on site. Okay. And so in the real world, if you have a code, you definitely decorate your composables using modifiers. So if you are interested in changing the shape of your composable or the size of the composable, you definitely use modifiers. And what the framework does in the composition phase is it wraps up all of those modifiers neatly on top of the existing nodes for the UI tree. Yeah, this is another look at how do you have like nested modifiers and all of the properties associated with the individual modifiers. And the important thing to keep in mind over here is modifiers wrap a single modifier or a layout node. Meaning, so if you have like different modifiers nested underneath one another, all of that gets nested under one single modifier in the UI tree. And that's how uh, it's the way how the compose framework performs efficiently under the hood. Now the framework moves along to the layout phase. Now this is where it refers to the UI tree and takes the dimension of the user's device into account, because every Android device is unique. It's not like iOS, like they come up with limited devices every year, like probably three. But Android devices are like really range from like extremely small screens, like probably 4 inches in resolution, to like 7 inches and whatnot. People have like tablets and TVs and whatnot. So the layout phase is all about figuring out the technical term for this is the window insets. The operating system measures all of the window width and height and then decides where exactly to place all of the elements from the UI tree. So this slide over here exactly talks about what I just mentioned. Like it measures the children. So first it takes into consideration the window insets of the device. It measures the children. meaning like you have a modifier for all of your layer of for your view groups and your composables in terms of width and height. It measures the children, decides its own size, meaning like the screen in its entirety, and then it places the children on its appropriate positions. Now, each node is visited only once. That is how Compose promotes itself to be a really efficient framework. Because back in the days of XML, the XML tree which got generated was definitely not popular for its like tree traversal algorithms. Now, people who are usually game developers, they often complain about how difficult it is to modify those individual views. As regular app developers, you may not see it, but a game developer would actually tell you the benefits of Compose using over XML views, because it's the way how the Compose framework has been designed. And yeah, here's just another visual representation of how all of those individual nodes from the UI tree are being placed as individual composables or views in the user's device. Now, moving along to the third phase, that is drawing. And this is where all of those attributes like colors and image resources are translated into the exact pixel data and rendered to the user, and the user is able to see your code getting translated into the actual UI. Now, let's move along to Compose lifecycle. So, this is kind of important in order to understand what are the different life cycle stages or the entry and exit points of your composables. Because what happens is in the real world events, or if you're working on like a massive production app or enterprise level app, you would definitely have like different activities and fragments. Depending upon the life cycle events, you can decide upon like certain successive operations. A very basic example is if you have a shopping app, and each time the user visits the shopping cart page, you would ideally want to track an analytics. It can be like a Firebase analytics or your custom analytics server. And depending upon the life cycle event which your shopping cart activity or fragment enters, maybe an on create or on start, you track your analytics code. But how would you do that in a pure 100% compose based screen? So the thing to keep in mind over here is there is no official life cycle terms which is associated with the entire composable operation. Now, these are certain phases which occur, and that's how the broader Android community have termed these phases as life cycle phases. So, number one is composition, the second is recomposition, and the third is removal. Now, there are tools as well in Android Studio to validate when your composable enters into composition and recomposition states. So let's take a look at all of those individual life cycle phases of a composable. So composition is the initial stage where the UI element gets created when the screen is displayed for the first time or recreated due to a configuration change. Now, a configuration change in your Android device can happen due to multiple factors. One of the basic examples is as a user, you rotate your device from a portrait to a horizontal landscape. It can also be when a person changes the default language of the device, maybe from English to French or French to Italian, and so on. So that is also considered like a configuration change. And there are like other events as well, which is available on the official Android developer documentation. So, and that is where your composable enters into the composition phase or the first rendering phase. So here's a basic example. You have a display composable and you have a text which says hello compose. And when you run the app, it enters into composition phase. Now, a recomposition occurs when the framework updates the UI elements when there is a change in the app state. Now, an app state is actually a global representation of how the user perceives your app screen at that given moment of time. So for example, if you have a list of let's say, yeah, let's take the shopping app into account. So you have a cart with two items added to the list, and then as a user you add a third item, the list of items changes. And that is when we say the state of the app changes from like two items to three items. So in that case, your composable would be updating itself and trying to show you the latest rendering of the UI as a user to the user. So here's an example. For example, if you have a composable with name display, and it takes a string name as parameter, and every time when you change the parameter, let's say I say it initial it is hello Sagar, and then eventually I change it to hello Paul, and every time the framework would be re-rendering itself, and this re-rendering of the UI is termed as recomposition. Now, the third one, now, few people also call it like uncomposition, but you can call it removal. Now, it occurs when the framework destroys and there are no more, the composibles are no longer required to be displayed on the user's device. So, for example, you have a display composable and you have a button, and the logic can be anything like you have a counter variable, and every time the user clicks on the button, the counter updates. But when you click on the back button or navigate to another screen, the composable gets destroyed. Now, uh, now let's see how would you handle like side effects, or let's say you want to track like certain operations at certain life cycle phases which we talked about. Now, a quick recap on what side effect is. So side effect is a term which is generally applicable in the world of programming, and what it means is any additional operation which gets executed on the side apart from the main intended operation. So for example, you have a shopping app and you place an order. So there are like different operations taking place in the foreground and in the background. Maybe in the foreground you want to show a visual update to the user saying that the order has been placed successfully, but in the background you also want to send out an email, you also want to send out a text message as a confirmation. So all of those can be termed as like side effects, whereas the main intended operation would be like a visual update to the user saying that your order has been placed. So in the world of composables, now you handle side effects in different ways. There are like multiple API extensions which is provided, but the ones which is primarily being used by the developer community is the launched effect and the disposable effect. Now, a launched effect is typically is used for starting a long running task. Now, those that long running task can be wrapped into like coroutines or maybe like custom thread and whatnot. So anytime you want a set of tasks to be executed whenever your composable enters into composition or recomposition state, you use the launch effect, and you associate it with a lifecycle owner. A lifecycle owner is responsible for observing your app's lifecycle state, because your app would be having different set of composables but at like different stages at different points of time. So a lifecycle owner kind of observes the lifecycle state of the app. Now, launch effect would be executing those set of operations each time your composable enters into your composition a composition lifecycle stage or recomposition lifecycle stage. Now, on the other side of the spectrum, we have disposable effect, which gets executed whenever your composable is about to be removed from the screen. So each time the user navigates out of the screen, and as a remainder task, probably you want to track some analytics, or probably you want to show a pop-up window or a dialog window to the user saying that, are you sure you want to back out of the screen, or some like additional operations that you want to do. In that cases, you can use disposable effect. All right. So Okay, I will take a quick look at the online question section, but I'll take a quick pause over here. And do we have any questions on the life cycle phases of the composables?
Well, sort of.
Mm-hmm.
Launched effect.
Mm-hmm.
It's not clear to me that you will always use a launched effect to start a long-running task. Um, I seem to recall uh, using the view model to initiate a long-running task as well.
Ye-
And
Yeah,
so now I'm wondering, what are the trade-offs and what are the benefits and what are the, when should I use one versus the other?
absolutely. Yeah, very good question. Now, the comment over here, it just says start a long running task, but it does not exactly tell you how to do it. Now, ideally, in the real world, if you're depending upon the architecture of your app, if it is MVVM or MVI or MVP, you use the appropriate instance. In your case, if it is a view model, then I would be imagining the composable would be having a view model argument over here as a parameter. Then you use the view model parameter inside over here. So let's say the view model variable name is VM, and then you do VM dot whatever operation you want to do. Yeah.
Okay.
Yeah.
Wouldn't it be that you might want to call a VM function inside the launch effect, right? It's either in a click listener, or if that's not happened, it needs to be on some component becoming visible. You do it in a launch effect. Is that the way you can do it?
Uh, Sorry, say that again.
Often you call a view model method based on an event, like a user
Mm-hmm.
click
Yes.
or a
Mm-hmm.
button press or
Yeah.
something like that. But you can also call a view model method in a launched effect,
Yes.
basically.
Yeah.
When a component becomes available, if the view model itself doesn't
Yeah.
do itself already by itself.
Yeah.
Right?
Yeah. So depending upon the type of operation that you want to perform, so a button click would be considered as like a primary operation, but a side effect is something that you want to do in additional to the main operation. So in both of the cases, we would still be using view model. A view model in like in the view model file will be having multiple methods or functions inside it. So maybe a function dedicated for performing the side effect, and there would be another function to perform the main effect. So for launched effect, you can use like VM dot the appropriate side effect function.
So now I think that really cleared it up for me because now it seems that launched effect is something that you will use when you don't have an action where there will be a handler that can kick off the long running task. So cool, that's great.
Mhm. Perfect. All right, let's take a look online. Okay, no questions. All right, now I'll show you one of my favorite parts of using the Android Studio IDE. So let me quickly stop sharing my browser screen and I'll share the Android Studio IDE. Let's see. Uh, Wait, no. Window. Let's see. I don't want to open
Is this the beat
this.
that you're interacting with?
Uh, yeah. Compose Camp. No, I better share the entire screen. That would work. All right. So, yeah. Now over here, this is the stable version of Android Studio IDE. So I have opened the Jet Snack project. Now folks can download it from the official Compose Samples GitHub repo. All you have to do is like in Google, just enter Jetpack Compose Samples and you will see a bunch of options, out of which Jet Snack is an option. Now the thing which I'm going to show you is applicable for any compose related app, so it does not really matter which app you are on. But essentially we're going to take a look at the layout inspector. So let's go to tools and let's see where that thing is hiding. Or maybe yeah, view tool windows, and there we go, layout inspector. All right. So I'm gonna wait for the layout inspector process to get attached to the emulator. Okay, perfect. Now, there is a neat way how we can detect the compositions and the recompositions of the screen. So let's see. Um, okay. So there used to be like a feature flag or like probably a config setting. So let me see if
I
they
think
have
you just had it.
listed down the line. Oh, did I hear someone
Yeah,
saying something?
go back to the eye
Okay.
for the view options.
Okay.
Are you looking for the show composition
There
count?
we go. Yes. Yeah. The
One up from the bottom.
recompose. Yeah. There we go. Thank you. Thank you so much. Yes. I was looking for that. All right. So now essentially every time I make an update, there should be like a counter showing over here. Let's see. Can I reset it? Yeah, for some reason it does not show up. But ideally, it should show up like a counter over here, like 1 and 2, and the number keeps on increasing every time your composable is entering into a recomposition state. But I don't know why that is not working out. Probably, yeah, I can restart my ID maybe. Let's see. Let's give it one more go. And let me restart it. Because that's one of the neat trick which I advise to every new or experienced engineer. So you might find like in your production app there might be unnecessary recompositions happening. So that might take like a really huge impact or a production hit to your app experience or to the user. So it's always wise to keep a track of all the unnecessary recompositions that is happening in your app. So let's take another look and see. Oh, why is it? Did I open? Yeah. Yeah, there's something weird going on. Maybe because I have two different versions of Android Studio IDE open. So let me close the
You were
developer.
attached to the Rally app. I think that was the problem.
Uh, yeah, I guess so. Yeah, I just closed the developer preview. It should work now. Fingers crossed. Oh my god. I wonder why it's still attached to Rally.
I think if you click on the Pixel 6 drop down, bottom left, you
Okay.
can select the app to look at.
Uh-huh. Yeah. So I'm just waiting for this project to finish building and then I'll just do it. Or for the time, I can just stop the inspector. Yeah, there we go.
Well, it's, building it's done. The question I was going to ask is pre composition, pre-composed. If I wanted to see this kind of information, there's a debug setting that you could use,
Mhm.
so that would show you all of the layout.
Okay.
And I, when you started showing this, I began to wonder if that still is available with Compose. Do you know off the top of your head?
No, I have always used like layout inspector. So is it like a config setting that you have been talking about? Like
It's a debug setting
in like ID?
no, not the IDE, on the
Yeah.
phone.
Okay. Oh, okay, okay. Yes. I think I know which one you're talking about. Yes, it is still available. But I don't think you can use it for seeing the recomposition counts.
Correct.
Yeah. Okay, so let's take another attempt at this. All right, it's the Jet Snack. We have got the layout inspector running. Let's see if I click on this. Nah. Yeah, for some reason it does not work. For folks who are attending online, you can give it a go in your ID, but yeah, sometimes Android Studio ID is weird, but most of the time it works. Ideally, when you perform any operations in your Compose related screen, you would be seeing a bunch of numbers being updated over here. And there would be like two different columns over here. One would be a recomposition count, and there is like a, if I'm not wrong, it's called skipped counts. So each time the a recomposition should have ideally occurred, but the operating system is skipping it. So all of those are like initial performance metrics to analyze what it takes in updating the UI, how frequently you are updating your UI. So it's like a really good performance metric. Unfortunately, it is not working right now, but yeah, this is something which you guys can keep in mind. All right, let's see. Let's close all of those things. Okay, now let's move along to the next thing. And yeah, the next thing is we'll be discussing about the Compose navigation. And we will be doing so by following a code lab. So for the code lab, let me go ahead and paste the link to it. For some reason, the link over here does not directly take you to the code lab, but it takes you to the Compose course first. So let me just quickly Google if there is an alternate link available to it. So I'm going to search Jetpack Compose navigation code lab. No. So, okay, let's go ahead and use this link. So I'm going to copy the link. I'm going to paste it in the chat. So folks who are online, they can go ahead and click on this link. Now, let's see what happens when you click on this link. Now, when you click on this link, you should either see the code lab directly, or you would see the Compose course, and which looks like a little bit different, but there would be like a navigation course assigned to it. So let me quickly show you that. So it's Android Compose course. Let's see. Yes. So folks who are online, when you click on this link, you would either see this code lab directly, or you would see this pathway 3 getting opened up. And when you click on explore, there will be like different topics, and you would be interested to expand navigation. And then there would be a button over here called take code lab. And when you click on it, it will take you to this particular code lab. Yeah, let me see if anyone is facing any issues. No, perfect. Okay, so I have already went ahead and downloaded the code base in advance just to save time. But we're gonna take our sweet time in walking through all of those individual steps, and we'll be taking a look at the existing app, which is called Rally. And we're gonna take a look at the existing composable structure, and we're gonna take a look at how Compose navigation works. So anytime you want to take a look at the final solution, you can take a look at the solution link embedded in the in the phase 2 or the setup phase of the code lab. So if you take a look at solution, yeah, it's gonna download like a zip file, so which you can open it in Android Studio and can check the ultimate solution. But I will be starting from the starting point. So let me quickly go ahead and pull up my ID. I prefer using the developer preview. So let me go ahead and open that. Okay. All right. Let me go ahead and start the app. For folks who think that this ID is looking unfamiliar, but this is actually the new ID to which JetBrains would be slowly be transitioning into, probably by the end of this year. And you can enable it from the settings in the ID. So you go to settings, and then you would be seeing an option called new UI, and you click on that, and you see your ID changed. Something to keep in mind is this is exclusive to developer preview for now, maybe in beta. I'm not sure, but yeah. Okay. Yes. So this is like a very simple app. I think this is more of like a finance tracking app, which is provided as an example by Google, and it's called Rally. Now it has three different screens, which is accessible from the top bar. So we have got an overview screen, which has like different composables or different sections called accounts, bills, and whatnot. And then we have an account screen, and then we have a bill screen. So each time you click on the icons, it will take you to those individual icon screen, the individual screens of your app. Now, for now, this app has been designed without compose navigation. So the way how they have done it in is like a very dirty way. I mean, it is doable. As we can see, the app is really working, but it is not recommended from an architecture standpoint or from like a best practices standpoint. And that is what they have mentioned in the overview as well. So if we take a look at the exact wordings over here, so you would they say inside you will find all the three main destinations, blah blah blah, as well as a single account. Um, Now there was a line which says, yeah, at the very top of the screen, Rally is using a custom tab bar composable Rally tab row to navigate between these three screens. Tapping on each icon should expand the current selection. So let's take a look at how Rally tab row
So
has
there's
been.
really no navigating going on.
No, it's like they have done it like in a very dirty way.
Yeah.
Yeah. So we can take a look at Rally tab row and how this looks like. There we go. Yeah, but this is the code which they are using. So anyways, it doesn't matter because we would be using compose navigation now. So we'll be removing all of this code, or yeah, we'll just comment it out and just create a new file and whatnot. But let's take a quick look at the project structure over here. So pretty much this appears like a typical compose project where you have just one activity with typical on create method, and then it sets the content and it calls Rally app composable, which sets the theme, and then eventually renders this tab row, if you may. And this tab row is calling the individual composable screens. Now, till the XML era, Google used to promote single activity and multiple fragments architecture. But over the course of time, fragments became really complicated to manage, especially if you have like a really mature code base. Fragments have their own set of life cycle, which gets attached to activities life cycle. And then over the time, it becomes really messy. And if you really don't know about life cycle management and stuff, it becomes your app performs like in a really weird way. So in order to overcome that, now it does not mean that there were entirely flaws in like fragment or jetpack navigation framework, but in the course of like improving things, the modern way of doing things in the world of compose is single activity and multiple composables. So that's how we would be learning in this code lab. So we have just one activity. We'll be using the API extensions provided by the Compose framework. It's called the navigation host and navigation controller, and we'll be implementing it to navigate to and fro amongst like different composables present in this code base. So let's take a look how we'll be doing it. So let's take a look at step 3, and let's ensure that we have understood it correctly. So yeah, there's an icon on the top bar, a string route, which is necessary for the compose navigation as a path. Let's see. So, okay. So we have got objects, overview, accounts, and bills, which is over here. And each of these screens are composables, and they have their previews. Let's see if we can see the preview. Okay, they haven't added a preview. Okay, that should be fine. And we have got a destination interface. So let's search for that. There we go. What's this one? Rally destination, which is inside. Yeah. So it's an interface which has like 3 variables: an icon, a route, and a screen. So the screen is actually where they are taking the composable itself as a parameter. And over here, they have created those individual implementations of that interface for different composable screens. There's one for overview, accounts, and bills. Now let's move along. Okay. Let's go to, yeah. So when you run the app, you'll notice that you can actually navigate between the destinations currently using the top bar. However, the app isn't in fact using compose navigation. That is what I was talking about. Like they have really slapped and created like a very dirty way of building an app. So, but it essentially works, but it is not recommended if you are a passionate software engineer and you are willing to learn the correct way of doing things. Now let's move along to see how do we do it correctly. Now, the very first thing which we want to do in this project would be to add the navigation library. So I'm going to go ahead and do that. So I'm going to copy this and add it to the app level Gradle file. So let's go ahead and open module. Yeah, Gradle file. And let's see if there is already a navigation. There is not. Okay, that's good. Okay, so I'm gonna go ahead and paste this instead of latest version. Let me quickly Google what's the latest version for this is. Let's see. I'll just search for theme. There we go. And it's 2.6.0. So do that. Let's sync that up. While it's syncing, let's take a look at the next steps for our code lab. Yes, so now we would be setting up a nav controller. Now, a nav controller is one of the essential components in the Compose navigation framework, which is used to actually switch from one of your, the technical term is destination. So from one source to another destination. So a destination is a composable in itself, and that is how you would be using a nav controller to switch from one composable to another destination composable. So let's see if the sync has been completed. Yes, perfect. All right, now let's move along. Okay, let me close Safari. Yeah. Okay. So yeah, a nav controller is a central component. Yeah, it keeps a track of backstack composable entries and stuff like that. Now, when someone says backstack, now essentially people who are familiar with Android development, if you have multiple screens in your app, the way how operating system manages the state of those screens is by building a stack data structure, one on top of the other. So essentially, if you have screen 1, then you navigate to screen 2, and then you navigate to screen 3. And as a user, you press the back button. The framework or the operating system need to know how to move back to the previous screen, and that is where a stack data structure is used, or the popular term which we used is called. It used to be called as activity backstack back then. Now it might be called as like composable backstack. But that is essentially what is being managed by the nav controller. So yeah, let's go ahead and see how we can implement it. Let's see. So inside the rally activity, let's take a look at how the composable is being set up. So we have set content and then we have rally app, and here's where the composable is being rendered. Now, what I'm going to do is I'm going to create an instance of nav controller over here. So I'm going to call this as var nav controller. There's something called as remember controller. Here we go. And let's see if they explain anything else. So yeah, a nav controller is obtained by calling remember nav controller function. This creates and remembers a nav controller which survives configuration changes. Now, earlier in the session, I said like a configuration change can mean different things. If it's like user rotates the device from a portrait to landscape orientation, or changes the locale or the language of the device, and so on. So each time a such configuration change occurs, you would ideally want to preserve the state of your app. As an user, you do not want to see any changes or different screens which is being used in the app. We can take a sneak peek at what exactly remember means. So a composable function can use the remember API to store an object in memory. A value computed by remember is stored in the composition during initial composition, and the stored value is returned during recomposition. So each time we learned about like different life cycle stages in composition and recomposition, and that is where it is important as an engineer to learn and distinguish different life cycle phases in order to appreciate all of these API extensions. So each time, so let's say you launch the app for the very first time, and your app downloads a set of initial data like user account information and other things like user attributes or preferences and whatnot. So each time your app or your composable screen enters into recomposition state, you do not want to refetch the data which you have already fetched. That is where you can use like remember. So remember is like one of the keywords which is provided as part of the composable framework, and you can use it in basically like any kind of variable. So over here, here's an example how you can use like val, mutable state, of, and all of those things. But essentially, these would be helping you to uh, retain the value of a particular variable across compositions and recompositions. Here's an example. These are like quick recap on like stuff which we already discussed in the previous sessions. So, for example, if you have var name by remember mutable state of a blank something, and then in the initial composition phase, you are checking like name is not empty, and then you're providing a text and stuff. So each time a recomposition occurs, the name of the assigned value to the name variable does not get refetched or recomputed. So as the name states, it remembers the value of that particular variable. Now so similarly, the remember API is also applicable for nav controller. It remembers the state of your app. Essentially, whenever there is a configuration change, it remembers what was the state of the app and in which screen the app was, and it retains it. Now let's move along. So routes in compose navigation. Yes, so they say they have 3 destinations. Yep, so we have an overview screen, an account screen, and a bill screen. Now the next step is to add these destinations in your navigation graph. Let's see what we mean by that. So let's see. Now, okay. Now they're talking about calling the nav host composable with a navigation graph. We will learn about it by coding it directly. So let's see. Now, there are 3 different parts of any navigation framework. This was also applicable for the classic Jetpack navigation framework as well. And it is also applicable for the Compose navigation framework. But essentially, that's nav controller, which we just created. There's a nav graph or a navigation graph, and there's a navigation host. Now, um, A nav controller, we said like it is in charge of maintaining the back stack of the app or the list of composable screens which you have, excuse me. A navigation graph provides us the details or the exact endpoints of the destination composables. A navigation host acts as a container and is responsible for displaying the current destination of the graph. So a container is nothing but like, so in the world of fragments, we also used to have like a fragment container. If you have an activity and you have an XML layout and you want to render a fragment inside it, maybe in terms of like, if you have like bottom tabs or like uh, hamburger menu layout, and then you click on those individual hamburger menu items or the bottom tab layout items, you have a fragment container, and inside the container you used to swap in and out all of the fragments. And then there used to be like fragment managers and all of those concepts. So essentially navigation host also acts in the same way. It provides a container, it reads from the navigation graph like what are the details it moves from it needs in order to swap one composable from another composable. So let's see how we can implement that in code. Let's see. So they are asking us to, I'm assuming we need to add this in Rally activity itself. Yeah, go back to Rally app composable and Rally activity, replace the box composable inside the scaffold. Let's see, do we have a box? Yeah, we have a box. And they're asking us composable inside the scaffold, which contains the current with a new nav host that you can create by following the code example below. So let's go ahead and do that. We have the inner padding, and I'm going to remove this box entirely. And I'm going to copy and paste this nav host variable over here. You go ahead and import the dependencies. Let's see, there should be, yeah, it should be this. Yeah. And essentially it is taking three parameters. So one is the nav controller, which we already declared over here. And then we have a starting destination, because if you have a container, the container or the host really needs to know what is the first screen that needs to be displayed to the user. And that is what essentially we are doing. So if you see over here, it takes overview.route, and this is how overview object looks like. It essentially implements the interface, and it tells us which composable that needs to be rendered. Now you can change it to either accounts or bills depending upon which screen you want to display to the user when you launch the app. So now let's, and it also takes a modifier, which it's all about like figuring out the dimensions of the navigation container which we want to display. Let me take a quick look in the online section. Any questions? No. Okay. Let's go back to our code lab, and the next thing which they are asking is adding destinations to the nav graph. Okay, so we talked about a nav graph is nothing but like a set of details provided for each of the composable screens which we want to display inside the nav host. So that is what we are going to build now. So let's see how the code lab is suggesting. So you can define your navigation graph and navigate to. Okay. The builder parameter expects a function. So navigation compose provides navigation graph builder.composable extension property. Okay. Now let's go ahead and see how different it is from the code which we already have. Oops. I keep on opening my Safari browser time and again. Yes. So essentially, the graph can be built something in this way. So you have the host over here, and in order to build an individual entry into the graph, we can write this composable keyword, and then we're going to import the appropriate extension function, that's navigation graph builder, and it takes a parameter as the route, and the composable which needs to be displayed. In this case, it's the screen. If you take a look over here, screen parameter contains the actual composable. Now, we would go ahead and do this for all of our destination screens. So each composable would be entered as an entry in the graph itself. So I'm going to copy and paste twice because we have 3 screens. And I'm going to replace this to, I think it's called accounts. Yeah, accounts.route. And this would be accounts.screen. This would be bills. That is how we build our navigation graph. And now let's take a look back at the code lab. Yep, essentially they are also suggesting the same thing. You build all of the entries in the navigation graph. Now run the app. You will see the overview as the start destination and its corresponding UI shown. We mentioned before a custom tab are the previously handled navigation. Okay, now let's see. Now the expectation is if I run the app, it will show me just the first screen, but it should not show the different screens. Is that what they're saying? Mentioned previously handled the manual navigation. At this point, it's not yet connected with the new navigation, so you can verify that clicking on the tabs. Okay, yeah. So essentially, yes, the very first screen which is picked up by the navigation host is the overview screen, and we have the graph build, but we haven't essentially made the right connections in order to perform the navigation. So if I click on those individual tabs, the composable of the screen is not getting updated. So even though it says bills, it still shows the overview screen. And when I go back to accounts, it still remains overview screen. Now let's go back to the code lab and figure out how we can make those connections. So step 5 is integrating the tab row, the rally tab row with navigation. So for this, they are suggesting, okay. So essentially, we would be using our new navigation controller to define the correct navigation action for the list of composables, which is described in the rally tab row. So let's take a look at rally tab row, which is over here. And do we have an on tab selected? We should be having on tab selected. Okay. And there's a rally destination, the current screen. Okay. Now, this callback defines what should happen when a specific tab icon is selected and performs the navigation action via nav controller, the navigation.route. Now, let's see how we can change it. So essentially, they are asking us, since we want the tab to navigate to a specific destination when tapped, you also need to know which exact tab icon was selected. So parameters this already, you will use that information, blah, blah, blah. Okay. Now let's do this. So we come back to rally activity, and then over here, we have the scaffold parameter and the rally tab row. And essentially, we would be replacing the on tab selected with our navigation API extensions. So this is the existing code where they have on tab selected and they are taking the screen parameter, which in turn like assigns the current screen value. We're gonna replace that with the navigation controller which we have. So I'm gonna, yeah, I'll just copy the comment from here so that we know that when we are making where we are making those changes. Now inside on tab selected, I'm gonna replace all of these screens and I'm gonna call this new screen. Now let's use the nav controller. Let's see, what do we have over here? Do we have a graph? Oh yeah, we have a navigate. Okay. Navigate, and it takes new screen dot route. Okay. So navigation controller comes with a neat API extension called Navigate, which takes the destination of a particular navigation graph. So this graph is built over here using all of these route information. Now let's take a look. If we run the app now, you can verify that tapping on individual tabs in Rally tab row does indeed navigate to the correct composable destination. However, there are currently two issues you might have noticed. So let's first execute the app and let's see if we can identify those issues. Let's re-execute the app. Okay, and we have got overview. We click on the account and we click on bill and it changes. Now the issue is it does not update over here in the Rally tab row. Previously, the Rally tab row was getting updated, but the screen itself was not getting updated. So let's find out why that is happening. So let's come back to the code lab. And yep, so they mentioned two issues. Retapping the same tab in a row launches multiple copies of the same destination, and the tab's UI is not matching the correct destination. So let's see if we can do that. If I click on overview, they are saying that it gets relaunched again and the tab does not get updated that we just verified. Now, so let's see how we can fix it. So launching a single copy of a destination. So essentially, right now, if I click on any of those tabs, you see the screen flickering. So that's how essentially the navigation controller is recreating the destination. Now, ideally, we do not want that. It is going to take a hit on the user's device performance. So let's see how we can stop that. Let's see, launching a single copy of a destination. Now, there is a parameter which we can use called launch single top. Let's see where we can do that. So for that, inside Rally activity, since you want this behavior across the app for every destination, instead of copy pasting this flag to all of your navigate calls, you can extract it to the helper extension at the bottom of your Rally activity. Let's see if there is a helper extension. Okay, so they essentially want us to create a helper extension. So we can go ahead and create that. So let me copy this entirely and paste it in the end of the file. Let's import all of the necessary classes. I'm gonna add a comment over here to say when's launching of multiple instances of composables. Now, let's see how we can use it. So we are calling the nav controller over here, .navigate. Now, instead of doing directly navigate, we can do navigate single top two. Now, essentially what this would do is, so right over here, we are just using navigate without any like special flags associated with it. But in the extension function, we are providing an additional flag and which is launch single top. So what that means, so we talked about this back stack, which maintains the list of composables as and when they are getting added to your navigation. So if screen A is on the top of the stack itself, we do not want to create another instance of screen A. And that is what this flag is going to do over here. So it means launch single top equals to true. If a screen A is present on the top of the stack, you do not recreate it. So let's replace the call from .navigate to the extension function which we have, and that's navigate single top two. And let's relaunch the app. Let's see if it has made any difference. So I'm in the overview screen and I click it and you see the screen is not flickering anymore. So essentially the Compose framework now has stopped recreating screens because this is like a very simple screen. In a production scale app, you would be having tons of composables, tons of state management data coming in and going out, animations, especially if it is a game app. You do not want to keep on re-rendering composables again and again, again and again. Very soon the app will run out of memory. Now let's see what we can do to fix the second error over here. So let's go back to the code lab and let's see what we need to do to fix the names of the tabs which we see over there. Let's see. So they're talking about controlling the navigation options and backstack state. Cover some additional options. Okay, so this section over here essentially describes the different types of operations which are associated with a backstack. Now, in the interest of time, I'll just skip this section because this section, like, I can dedicate an entire section talking about like activity backstack or composable backstack. There are like different flags associated with it. Flag top is just one of the flags out there. There are like multiple flags, and stack has like its own set of operations. For example, over here, pop up to and whatnot. In the interest of time, let's move to fixing the tab UI. But yeah, folks who are online, give it a go reading this particular section, just controlling the navigation option backstat over here. And if you have any questions, feel free to mention those in the Compose channel, which we have in the Slack group. So let's take a look at fixing the tab UI. Let's see what they suggest over here. So essentially, let's see. So at this very start of the code lab, we are still using manual navigation. So we overcome that definitely. Now to get real-time updates on your current destination from the backstack in the form of a state, you can use nav controller current backstack entry as a state and then grab its current destination. So in order to do that, okay, so they are asking to create a current backstack. So let me go ahead and copy and paste this, and I'm going to explain in a while what this is about. Now let's go back to Rally activity. Inside Rally activity, inside the composable, yeah, beneath the nav controller, let me create this variable. And let's implement this. Okay. Okay. Now, in the beginning of this session, I explained a little bit about state, but state of an app is essentially the visual representation and the associated attributes of your app. Now, essentially, nav controller comes with like neat API extension with which associate the backstack with a state of the app. So over here, we are creating a variable called current backstack, and then we are using the API extension, which fetches the backstack entry as a state. The name of the function speaks for itself, like what it exactly does. So you can take a look at the source code as well, and it will explain more in the kdocs, like how they are converting the entry of the backstack itself in terms of a state over here. But the name of the extension function speaks for itself. So now let's take a look at what's the next step. So we're gonna fetch the current destination from the backstack. Now that's essentially doing like creating a new variable called current destination. And current backstack can be nullable. So definitely there might be a chance like there are no entries in your backstack. Now for null safety, we are using the question mark operator for Kotlin. So now essentially, let's copy this, the current screen over here, then paste this over here. What this does, change the variable to this and use overview as a backup screen if this returns null. Okay, so I think we get rid of this existing current screen. For now, I'm just gonna comment out the current screen. Rally tab row screens and whatnot. So now let's go ahead and execute this. Let's see if this has fixed it. Yes, it is. It has. Okay. So essentially, what we did was we got a control over the back stack as a state. We got the current destination of the back stack, and then previously we had a current screen which was using a remember mutable state of to identify what is the state of the screen which was being used in the app itself. But we modified it to so it would still be referring to rally tab row screens, which is a list of all of the composables which we have over here. But essentially, within the list, we are finding the route of the composable which matches with the current destination from the backstack. So each time you click on the tab over here, the backstack changes. You had overview as the top element of your backstack. Now account gets added on top of the backstack. So destination over here changes. So accordingly, it finds the matching route of the current destination with the list of routes which we have, and it updates the tab row composable. So essentially, this in its entirety is Compose Navigation Framework. Pretty much easy. We have three different elements: a nav controller, a nav host, and a navigation graph. To quickly recap what those three things do, navigation graph essentially has all the entries of the list of screens which you have for the app. Navigation controller manages the back stack, it as like a stack data structure, one composable on top of each other. And the main player or the main coordinator in the entire navigation framework is the navigation host, which controls the flow between navigation graph and the navigation controller. And that is how the entire architecture of a composable app performs. So you have a single activity and you have a navigation controller. You have a bunch of composables listed as navigation graph entries. And as a user, you click on those individual buttons or tabs or whatnot. The navigation host takes care of switching from one composable to another composable. Yeah, I think this is the correct time to take a pause. Essentially, we are about time, but I can reserve the last 10 minutes for any questions. So, any questions in general? Anyone from online? Let me take a quick look.
I have questions, but I'll
Yeah.
defer to other people because the two questions, the two things that I want to talk about are probably advanced topics. So
Mhm.
I'll hold back until.
Okay, no
we
problem.
answer other questions.
Okay, let's see. Do we have anything online? Yeah, no questions online. You can go ahead.
Okay, cool.
Mhm.
All right. One of the first issues that has arisen in my use of Compose
Mm-hmm.
was I became convinced by reading some documentation online that this Compose navigation was weak because it's based on strings, so it is not type safe. And there was a library suggested called, I think it's Ram Costa Compose Destinations. And are you aware of this issue, and do you have any comments about it?
Personally, I have never identified any issues. Maybe because we as an organization haven't dived deep into it. Our use cases have been satisfied using Compose Navigation Framework, but I would love to learn more about the library. Can you please name that again? I can do a
It's
quick Google.
Compose Destinations. It's written by a guy named Rafael Costa. And,
Okay.
I got hold of it via
Oh.
Philip Lackner. He talked about it and convinced me that it was the greatest thing to use. And then when I tried to break my UI
Mhm.
layer apart into different projects,
Mhm.
so each project corresponded with one UI feature.
Okay.
This Compose Destinations started to get in the way. And so I'm winding up having to kind of lose Compose Destinations and go back to
The regular way.
standard
Okay.
Compose Destinations. But
Mhm.
plot thickens. The second issue is nested navigation.
Mm-hmm.
I believe because I've got my UI split into separate libraries, that I need to use nested navigation, and I don't really have a good grasp of nested navigation yet. And so I throw it out. Are you familiar with it?
Personally, I have never tried nested navigation in the compose way. I have tried nested navigation in the classic Jetpack navigation way,
Yeah.
which is very complicated. Yeah, honestly, not more one of my favorite parts. But no, I have not tried like any nested compose navigation. But if I have a code, I can take a look and I can figure out what's going wrong.
Okay, I'll
Yeah.
keep that in mind.
Mm-hmm.
Cool.
For sure. And did you say like, well, using Compose destinations, did you have like multiple feature modules for UI in your project?
No, I only had one.
Okay.
It was a monolith.
Okay. Yeah.
All my UI code is in the same module,
Mm-hmm.
and I want to split it apart. I've hesitated splitting it apart because if I do that, then I need to grasp how to handle modules for composed destinations. But I've also picked up signals from Ian Lake,
Mm-hmm.
Google, one of the Google advocates,
Mm-hmm.
who says that composed destinations is going to change. Not composed destinations. Composed navigation
Mm-hmm.
is the standard one is going to change so that it is more type safe. And he makes the argument that while it's not statically type safe, it is runtime type safe, which is, I guess, something.
Yeah.
But so
No, for sure. Like Compose as a library is still evolving. Google is continuously taking feedback from a lot of developers. So I wouldn't be surprised like if they would be coming up with like major improvements in a very like short period of time. So yeah, we'll see how that goes. Yeah. Oh yeah, we had the same question online as well. Yeah, about the navigation library,
yeah, cool.
Compose destinations. Yeah. Alrighty. Any other questions from online folks? Well, if not, that's about it for today. Thank you for your time. Thanks for joining.
What's up next week?
Oh, it's thank you. Next week on agenda would be Compose testing and probably like advanced architecture. We would probably talk about like MVI or MVVM because Google officially recommends MVVM if you refer like official documentation on Android developers documentation. But MVI is like being fast adopted amongst the community. It's like sort of becoming the
I don't get it.
really, you're not a fan of MVI?
Document is standardly typed. Why do you need MPI?
Yeah.
Why wrap everything in an event with data
Yeah.
and then unwrap it again in your view model? You get this big statements like when statements is you have methods.
Yeah. Yeah,
Which are,
it's
you know,
debatable.
according
Yeah.
to small talk are messages, right? So
Yeah.
let's call these methods. MVM is good enough. It's not
Yeah.
reducing and
Yeah.
syncing and
That's a really good topic. Now the entire community is actually no, absolutely no. It's a very good like debatable topic. So inside our organization as well, like we have an equal split. There is a camp MVVM and there's like a camp MVI. There is
for
like
React Native, it's great for JavaScript.
yes, yeah.
Yeah.
Yeah, I mean MVI itself was like designed purely for like declarative approaches. So yeah. So we're gonna take a look at like those subtle differences on MVI and MVVM. So we have got like 2 sessions remaining. So next session probably I can talk a little bit about testing strategies because I remember one gentleman from the first session explicitly requested like, are we taking a look at, was it you, Paul, or someone? Yeah. Yeah, it's the first session, and someone requested about learning about like testing strategies, like testing libraries or something. Yeah.
I'm very interested in that.
Yeah.
And in particular, code coverage.
Yeah.
And near as I can tell, the code coverage story for Compose is still horrible. It's non-existent.
Yeah.
But the testing topic is very interesting, and there's a lot.